Okay, sorry. Yesterday also the same problem I faced. Today also it is showing the same. Okay, so write down. I will repeat that previous question once. So both the bits. How will you infer with the help of an experiment that the same current flows through every part of a circuit containing three resistors in series connected to a battery? B. Consider the given circuit and find current flowing through the circuit and potential difference across 15 ohm resistor when the circuit is closed. Okay. So first bit they are asking how will you infer? Okay, that is a theory question. If all the resistors are connected in series, then how much current will flow every part of the resistor? Okay, that answer is very easy because in series connection, and in series connection current across each component will remain same. Okay, and here this is what the diagram they gave. Okay, this is the given diagram and here key is there, and when key is closed current is flowing through this. Okay, so resistors are given 5 ohm, 10 ohm and 15 ohm. Okay, so first part you have to write the derivation. You have to prove that R is equal to R1 plus R2 plus R3. That yesterday also I discussed. Those who don't know, they can check the previous video. Okay, you will get the idea how we prove that. So here they are asking total current from the circuit and voltage across 15 ohm. So here check each resistors are connected back to back, means one end and a new one is initial end, and this is end and it is new end. So they are connected in series one by one. So as this is a parallel series combination, and here 30 volt battery is provided. So here total resistance in series is nothing but R1, R2 plus R3. Always remember in board exam whenever we are attempting these questions, always find out whether the circuit is in a parallel or series. If it is parallel, okay, or it is series, then always write the basic formula first. So for writing correct formula you will get half mark. Like that you can start grabbing half mark everywhere. Okay. So now here R1 is given 5 and then R2 is given 10 ohm and R3 is given how much? 15. So 15, 10, 5 plus 10, 15 plus 15, 30 ohm is nothing but what? The total resistance of the circuit. Okay. So they are asking potential drop across 15 ohm. Okay, that means of course this is a series circuit. Current through the entire circuit will remain same, but potential drop across each component is different. So here they are asking across the 15 volt. Okay, so you should connect a voltmeter over here and calculate the V. So here we can apply Ohm's law. Okay, and you can write V is equal to IR. Again writing this statement and formula you will get half mark. So here I am interested in V. So current will remain same. So current, do you know how much? No, what they are asking, current through the voltage across it and find out the current also. So without calculating current we will not get the voltage across 15. So calculate the current Ohm's law only. I is equal to V by R. Okay. So here total voltage of this circuit is 30. Total resistance we are getting 30. So current is nothing but 1 ampere in the circuit. Then calculate the voltage drop across 15. So V is nothing but IR. So current is 1, that will remain same. Resistance across 15. So multiply here 15. So voltage across 15 is nothing but how much? 15 volt. Okay. So don't forget to write the units. You check everywhere. If I am in rush also, I will not forget here to write the units. See, resistance which is measured in terms of ohm, current which is measured in terms of ampere, and voltage we are measuring in terms of volts. Okay. So copy this. I hope everyone understood this. Getting this? Check once properly. Okay. Okay, write down the next question. Write down next. Three resistors R1, R2 and R3 connected in parallel. You can take a screenshot, okay? The first one, write down next. Three resistors R1, R2 and R3 are connected in parallel. Are connected in a parallel and the combinations is connected to a battery to a battery parallel and combination is connected to a battery ammeter, voltmeter and key, full stop. Draw a suitable circuit diagram. Draw a suitable circuit diagram and obtain an expression for obtain an expression for equivalent resistance of the combination of the resistors. Equivalent resistance of the combination of the resistors, full stop. Write down next bit. Calculate the equivalent resistance of the following network. Calculate the equivalent resistance of the following network. Okay. So I'll repeat the first one. Three resistors R1, R2 and R3 are connected in a parallel. The combination is connected to a battery, ammeter, voltmeter and key. Draw the suitable diagram and obtain an expression for the equivalent resistance of the combination of resistors. And B, calculate the equivalent resistance of the following network. Okay. So start doing first one. Okay, so first one is what? They are connected in parallel. Okay, already I discussed this theory in the last video, but still I will revise you once. Okay, so they are asking here to derive the expression for the same. Okay, so here you can show parallel combination, three resistors, show it. Okay, practice this derivation and diagrams every day. Okay, then only you can able to draw quickly in the exam. So here you can connect ammeter and then here we can connect a battery. This is a key. Okay, voltmeter you can connect across this. Okay, so here you will get voltage. Okay, like this you can show the diagram. This is I, this is R1, R2, R3, voltage, or you can write battery, and this is key. Like this you have to draw the figure. Okay, parallel combination is there, that means you have to prove. In parallel combination current is different, okay, in each branch, but voltage across R1, R2 and R3 are remain same as this is a parallel combination. Okay, so here how to prove this? We know that total current is nothing but I1 plus I2 plus I3, because current is divided, because current in each branch is different here. So here We know that V is equal to IR. So I is nothing but V by R. Voltages remain same in the parallel combination. So I will write V by R and here V by R1, V by R2 across V by R3. Okay. So V by R I will take V common 1 by R1 plus 1 by R2 plus 1 by R3. So V and V get cancelled and you will get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is nothing but what the total resistance in the parallel circuit we will get. So this is what the derivation. Okay, we can do this as a derivation. So very easy. Practice it every day, then only you can able to solve. Now they gave here one combination. Okay, I hope you understood. We did this in the last class also. You can take a screenshot of this. Then for the second bit, they gave a diagram. This is what they gave the diagram for second bit. Can you able to see this diagram? Can you able to see this diagram? Okay, so now I will write down the values which are mentioned over here. So here this is terminal A, this is terminal B. Okay, and this is 10 ohm, this is 20 ohm, and this is also 20 ohm. So they are asking here, find out the equivalent resistance of the network. Okay, equivalent resistance only we have to calculate. That is, see, these two are in a parallel. Who? These two are parallel. Why? Because when the current will come, it gets divided into two different branches. Correct? So this is what parallel. So I will solve this first. So I will write 1 by R is nothing but 1 by R1 plus 1 by R2. So this is 1 by 20 plus 1 by 20 is nothing but 2 by 20 is nothing but 1 by 10. So here 1 by R is nothing but 10. So I will write it as Rp. So Rp is nothing but I will get 10 ohm. So now I will modify the diagram here. So this is what 10 ohm which is there here. Okay, and now I will reduce and I will draw only one resistance, equivalent resistance, that is also 10 ohm. This is your terminal A and this is your terminal B. Now this Rp and this 10 ohm are in series, no? So here again total resistance we will get it as R1 plus R2 is nothing but 10 plus 10 is nothing but 20 ohm. So this is the equivalent resistance of the circuit. So always try to find out first whether it is parallel or series, then simplify, then again draw a simplified diagram and then again solve for the next calculation. Go for the next calculation. Can you getting what I am saying? Okay. So I hope you are getting what I am saying here. Copy this or take a screenshot. Okay. Then write down next one. This is little bit different. Make it IMP. This question. Consider a conductor of resistance R. Consider a conductor of resistance R, capital R. Length L, capital L, comma, thickness D, small d, and density rho. Okay, rho, how you are writing? Rho is a density. Rho you can draw it like this. Okay, so rho, full stop. I'll repeat the statement again. Consider a current of resistance, conductor of resistance capital R, comma, length capital L, thickness small d, and resistivity rho. Okay, full stop. Now this conductor is cut. Write down. Now this conductor is cut Now this conductor is cut into four equal parts, four equal parts. What will be the new resistivity? What will be the new resistivity of each of these parts? Of each of these parts, and why? And why? Okay. Second part, write down second bit of this question. Find the resistance. Find the resistance if all of these parts are connected in parallel and series. Parallel and series. Third bit of this question, write down out of the combinations of resistors mentioned above in the previous part for a given voltage, which combination will consume more power and why? Okay. So we will repeat this entire question one more time. Those who missed, they can write down. Let the conductor of resistance capital R, length capital L, thickness small d, and resistivity rho. Now this conductor is cut into four equal parts. What will be the new resistivity of each of these parts and why? Second, find the resistance if all these parts are connected in parallel and series. Third, out of the combination of resistors mentioned above in the previous part for the given voltage, which combination will consume more power and why? Okay, so this is little bit application oriented question. Okay, so we have one conductor here whose resistance is R and length is L and thickness is nothing but D and resistivity of the material is given rho. Okay, so here diagram and all is not required. Okay, so we have to just write down the combinations and how they cut it into different parts, that we have to focus. Okay, so here they are asking first one, now conductor is cut into four equal parts. What will be the new resistivity of each of these parts and why? So here see the resistivity is rho here. Okay, and whose length is capital L and whose thickness is small d. This is what mentioned over here. So resistivity will not change because it depends on the material of the conductor. So this conductor is made up of a same material, then its resistivity will not change. No, if you are cutting into 4 parts, 100 parts, that doesn't matter. Okay, so here resistivity will not change. So first का आंसर आएगा rho will not change. Rho will not change as it is made up of what, or it is depends on the material of the conductor, as it depends on the material of the conductor. So very simple answer, which we know that R is equal to rho L by A. Okay, so there we discussed all these things. So rho will not change, okay, as it depends on the material of the conductor. And here material, if we are using same for all parts, okay. So we are cutting the same conductor, so rho will remain same, it will not be changed. So this is the answer of first bit. Why also they ask why ka answer I wrote, because it depends on the material which we are using. Okay, now second part, find the resistance if all these parts are connected in parallel and series. Okay, so how to find out this? Here total length is nothing but capital L, no? So you are dividing into 4 equal parts. So total length means here one part if you take, then that length will become what? 1 by 4, no? Or L by 4? Can you getting what I am saying? Can you getting? For getting second part, L will become L by 4. Okay, rho R is nothing but rho L by A here. So we are dividing this entire conductor length into 4 parts, 4 equal parts. So here we will get it as L by 4, or we can write this rho is equal, R is equal to rho L by 4 times of A. Can we write it like this? Can you getting? So as here area of this cross section will remain same. Okay, that we can consider A as a constant here. Okay, we can take A as a constant. Okay, then how can we find out each part ka resistance? We will get how much now? Each part of resistance here, R is equal to, I got rho L by A. Okay, so can I write this L as A as 1 upon A? Check. Yes. So I did this, take a rho L by A. So cut it into 4 different parts. Then what is the total resistance of this circuit? We have to calculate. Okay. So how to solve this? Parallel and series. So these resistors you can connect in parallel as well as in series. Okay. So here R is nothing but what you will get? One part, or we can say that resistance of each part is nothing but here how much? Total resistance divided by 4. Okay, so this much you will get, because here see rho L A are nothing but constant. Okay, and that we can equate it as a R. So R by 4 is each part. So now each part is connected in series and parallel. If you are connecting in series, suppose if I am taking here series first, series combination, and in series combination RP is nothing but what? R by 4 plus R by 4, because it is converted into 4 parts, no? R by 4. So that is nothing but 4R by 4 is nothing but what? R. So total combination in a series we are getting RS is equal to R ohm. Okay, you can write the unit R ohm, and in parallel we can say that we can write parallel 1 by Rp is nothing but 1 by R1. So R1 is nothing but R by 4 plus 1 upon R by 4 plus 1 upon R by 4 plus 1 upon R by 4. So 4 is get reciprocal here, 4 by R, 4 by R, 4 by R plus 4 by R. So that is nothing but how much you will get? Check now. In parallel combination we will get it as 4 plus 4 plus 4 plus 4 is nothing but 16 by R. This is 1 by Rp. So therefore Rp is nothing but R by 16. So this is what we are getting the answer, R by 16 ohm. This is nothing but equivalent resistance in the parallel combination. Okay. And last part they are asking out of this combination of resistors mentioned above in the previous part, for a given voltage which combination will consume more power. Okay, so power, we know that P is nothing but V into I, but this formula will not work for here, so we have to adjust this. Okay, substitute here I is nothing but V by R. So V by R, that is nothing but you will get V square by R. Okay. So here whose resistance is more, their power is what, less. So here more is what, this one. Resistance which we are connecting in R, the total resistance is nothing but R. And here total resistances get divided by 16, means value is what, RP. RP we are getting minimum. Even in the last session I told you the resistances which we are getting in the parallel combination is always less than the series, or we are getting minimum resistances in the parallel and maximum resistances we are getting in a series. So here in series combination we have a maximum resistance, means power consumption is here maximum resistance, then power consumption is less. And in parallel combination the resistance is less, then power consumption is what, more, because P is inversely proportional to R. Remember, whose resistance is greater, their power consumption is less. Whose resistance is more, their power consumption is less. And here whose is less resistance, their power consumption is more. So who will consume more here? Parallel combination consumes more power. Can you getting this? समझ में आ रहा है? Okay. So write down the fourth part, that is last part, that is parallel combination consumes the more power. Parallel combination consumes more power. Okay. Okay, finished. Okay, write down one more question. Find out the following. Find out the following. Find out the following in the electric circuit. In the electric circuit given in the figure, full stop. Answer any 4 questions from A to E. Answer any 4 questions from A to E. Write down the questions, then I will draw the diagram. First question, effective resistance of two 8 ohm resistors in the combination. Effective resistance of two 8 ohm resistors in the combinations. First option 4 ohm. Second second 16 ohm, 16 ohm, third one 8 ohm, okay, 8 ohm, last is 1 ohm, last is 1 ohm, okay. I will repeat. Effective resistance of two 8 ohm resistors in the combination. First is 4 ohm, second is 16 ohm, third one is 8 ohm, fourth one is 1 ohm. Understood? So write down the next B part. B part, current flowing. Next question, current flowing through 4 ohm resistor. Current flowing through 4 ohm resistor. Write down the option. 1 ampere, 1 ampere, 2 ampere, 2 ampere, third 8 ampere, 8 ampere, then last is 4 ampere. Write down third question. Third question, potential difference across 4 ohm resistor. Potential difference across 4 ohm resistor. First option 1 volt, second 2 volt, second 2 volt, third 4 volt, and last is 8 volt. Then next, write down the question. Next question number 4. Power dissipated in 4 ohm resistor. Power dissipated in 4 ohm resistor. Power dissipated in 4 ohm resistor. First option 4 watt, second 2 watt, third 1 watt, fourth 8 watt, fourth 8 watt. Okay. Last question, difference in readings, difference in readings, difference in the reading of ammeter A1, of ammeter A1 and A2, A1 and A2. Write down first bit will become double, first bit will become equal, second bit will become half, will become half, will become half, okay. Third remains the same, remains the same, and fourth one is 8 ampere, and fourth one is given 8 ampere. Okay, these are the questions for the diagram. Okay, now I will draw the diagram here. Okay, and now try to find out the answers. Okay, so yesterday also we did the similar question. So I will draw the diagram here. This is A1, this is A2, this is 8-volt battery. Okay, this is 4 ohm, this is 8 ohm, this is also 8 ohm. Okay, so this is positive, negative, negative, positive. So here the branches they are giving A, B and C. A, B and C. Key is also given here. K. Okay. This is what the diagram given. The effective resistance of 8 ohm resistor in the combination. Effective resistance of 8 ohm. These are two. Okay. So always immediately once the diagram comes, then you have to check the current. So current is divided in both the branches. That means this combination is nothing but parallel. ओके सो फर्स्ट के लिए देखो पैरेलल कॉम्बिनेशन है 1/Rp इज नथिंग बट 1/8 प्लस 1/8 नथिंग बट 2/8 दैट इज नथिंग बट 1/4 so Rp is nothing but what 4 ohm so check the option for first question first option के लिए answer is A only okay खलास we got the first question then part B के लिए पूछा है current flowing through 4 ohm resistance okay how much current will flow through this across the 4 okay so how can you calculate here you have to calculate first to get the current see in this question we will not get the answer directly okay so you got just now this Rp I told you to draw the modified diagram okay so this is what battery this is 4 ohm resistance and then new resistance which we got for this combination equivalent is 4 ohm this is also 4 ohm and then we have here something key and ammeter and this diagram so again these two resistors are in series so R total we will get it as a R1 plus this Rp is nothing but 4 plus 4 that is equal to 8 ohm is the resistance total resistance once you get total resistance then only go for the calculation of a current total current from this circuit because for 4 ohm current will remain same because this is series okay with this combination so here we can calculate current by Ohm's law V is equal to IR so I is nothing but V by R so total voltage is given 8 and total resistance we got 8 so here 8 by 8 is 1 so total current through this 4 ohm resistance is nothing but 1 ampere now check the answer which one is correct yeah again option A is the correct option okay now go for the C potential difference across 4 ohm resistor potential difference across 4 ohm resistor we have to calculate so potential difference across 4 ohm so voltmeter is connected in parallel over here so to get the third bit potential difference V is equal to IR so I just now I got 1 and R is nothing but 4 so answer is nothing but 4 volt so check which answer is correct third option is the correct option okay or correct answer now next power dissipated in the 4 ohm resistance so power dissipation P is nothing but what V into I voltage across they are asking 4 no voltage we got it as across 4 means this voltage you have to take that we calculated as a 4 and current we have 1 so power is nothing but here 4 watt okay so this is the answer and now which option is correct here again first option is the correct option okay and now they are asking difference between difference in the reading of ammeter A1 and A2 so here we know that this is A1 and this is A2 current measures here is 1 ampere no and here is also 1 ampere it will remain same for the entire circuit okay because this parallel this is nothing but what series combination so here current will remain same current will not divide this equivalent diagram so we are joining ammeter here or here you will get the same current okay so answer for this is nothing but third one which is remains same so this kind of 4 mark question can also they ask very simple go step by step think properly and then solve and across which resistor they are asking voltage, current or potential drop, that you can check it properly. Okay, getting this all? Okay, today I finish this everything. Then do one thing, today you can learn the symbols, because symbols also they will ask. So I am telling you what are the IMP parts from this chapter. You have to do the derivation for parallel and series combination derivation you can do. Then Joule's law of heating. Then that nichrome, tungsten wires are there, fuse and all, that part you have to do it properly. Okay, most of the questions will come from that. Okay, so okay, I will ask you the questions, you can listen, and I will ask one by one, so check what are the this thing answers. Okay, so here um, question is asked here, MCQ is there, easy MCQ I will ask you orally. What is being measured using the voltmeter? Okay, what is being measured using the voltmeter? First option, current in the circuit, voltage in the circuit, C, voltage across the resistor, and resistance offered by the resistor. देखो हाँ, options are given, current in the circuit, voltage in the circuit, voltage across the resistor, and resistance offered by the resistor. Voltmeter measures what? So here voltmeter measures the voltage, no? So here this voltmeter, they gave two options, voltage in the circuit and voltage across the resistor. So voltage, it measures the voltage across the resistor. Okay, that is the correct option. So now write down next question. You can write down next question. Which of the following is not correctly matched? Which of the following is not correctly matched? Okay, so they didn't ask direct symbols here, but they gave us symbols. Which of the following is not correctly matched? Write down the options here, means draw the diagram, and they are asking the question on this. So here first one is given. Okay, and they are saying this is an electric cell. This is an electric cell. Then B, this is a resistor. Then C, last part, that is open plug key. Okay, and options are given. First option is A, second option they are asking B, C, last third option they are asking B given as B and C, and D, last option is nothing but D. Okay, so these are the options they gave, and the question is this, which is not correct, they are asking. Okay, which is not correct. So this is electrical cell, correct. In cell we have only one positive and negative terminal. This is resistor, we know. This is what? Closed key, no? This is nothing but what? We have a closed key. But they are saying here open plug key. So now tell which answer is the correct answer here. Here which answer is correct? Option D is the correct option. That is the last option. Okay. So this is nothing but what your answer. That's it. Getting this? Okay. Write down next one. Coulomb, no need to write, I will ask orally. Okay, Advait can answer this question. Coulomb is the SI unit of first charge, B current, C potential difference, D resistance. I will repeat. Coulomb is the SI unit of charge, current, potential difference and resistance. Yes, Advait, type your answer. Advait, type your answer. Coulomb is the SI unit of electric charge. Okay, Shabas. Then next question. Azra, you can answer. 1 millivolt equal to. I'll repeat the option. 1 millivolt equal to 10 volt, 1000 volt, 10 raised to minus 3 volt, D 10 raised to minus 6 volt. I will repeat. 1 millivolt is equal to 10 volt, 1000 volt, 10 raised to minus 3 volt, 10 raised to minus 6 volt. So which is the correct option? Millivolt is given. Okay. Milli means how much? Ten raised to minus 3. Yes, correct. Correct. Now next one. Now write down. The temperature of a conductor is increased. The temperature of a conductor is increased. The temperature of the conductor is increased. Full stop. The graph best showing the variation. The graph best showing the variation. The graph showing the best variation of its resistance. And draw the diagrams. This is first bit, second bit, third bit, last bit. Okay. So now check. Here the temperature of a conductor is increases. Then which graph which shows the correct option over here. Okay. So which one is the correct option? So here the temperature of the conductor they are saying increases. Okay, and at least by observing this graph you will come to know that temperature and resistor is given. So always remember this resistor is directly proportional to temperature. So temperature increases, resistance is also increases. So here we have this graph is correct. Option A is the correct option over here. Okay, all the basics which you learned in this chapter you have to apply while solving this kind of questions. Okay, so I hope you got the option A. Then chalo write down next one. uh, two devices are two devices are connected between 2 points, say A and B, in parallel, full stop. The physical quantity that will remain the same between the 2 points is. First, I'll repeat this. The two devices are connected between 2 points, say A and B, in a parallel. The physical quantity that will remain same between the 2 points is. First option current, second option voltage, third option resistance, fourth option none of these. Okay, so Hriday, you can answer this. What is the answer? Yes, Hriday, can you answer this? This is a parallel combination. So which value will remain same here? Hriday, are you there? What is the answer? You are sleeping? Which value or which quantity will remain same? Advait, tell me. Advait, which value will remain same when the combinations are parallel? Yes, anyone? Those who are attending, which combination is there? Okay, very good. Very good. Okay, those who are present now, tell me in parallel combination which quantity will remain same? In parallel combination, voltage will remain same. Okay, so here those who are messaging also, they are also sleeping. Okay, so option is the B, because devices are connected in a parallel combination, then voltage will remain same between the 2 points. Okay, write down next. A fuse wire repeatedly gets burnt. A fuse wire is repeatedly gets burnt when used with a good heater. When used with a good heater, full stop. It is advised to use a fuse wire off. It is advised to use the fuse wire off. First option, more length, B, less radius, C, less length, D, more radius. I will repeat this. A fuse wire repeatedly gets burned when used with a good heater. It is advised to use a fuse wire of first more length, less radius, less length and more radius. Very IMP question. Okay. So what is the answer of this? Can anyone? So here fuse is getting heated again and again. In order to get the working of heater properly, fused wire of higher rating must be used. Very important. Fused wire of higher rating must be used. So option D is the correct option over here. Getting this? Okay. So okay, then write down next questions. Students students carries student carries out an experiment. Student carries out an experiment and plots the VI graph and plots the VI graph of three samples of nichrome wire of nichrome wire nichrome wire with resistances R1, R2 and R3 respectively. R1, R2 and R3 respectively. Which of the following is true? Which of the following is true? Okay, I will repeat this. A student carries out of an experiment and plots VI graph of three samples of nichrome wire with resistances R1, R2 and R3 respectively. Which of the following is true? Okay, first first draw the diagram and then go for the options. Then I will give you the options. Okay. So these kind of questions are very important for the board point of view. Okay. So draw here voltage across ampere. So this is volt and this is what I. Okay. And the graph is given. So this is R1, R2 and R3. Okay. And options are given here. First option, that is R1 is equal to R2 is equal to R3. Second option, R1 is greater than R2 and R2 is greater than R3. So third option here, R3 is greater than R2 is greater than R1. And last option, R2, R3 is smaller than R2 and it is greater than R1. Okay, so this is what the options they gave. So here along the y-axis current is there and along the x-axis we have a voltage and we have to find out the correct option over here. Okay, write down this is R3 here. This is R3. Getting this? Okay. So how to solve here this question? This is also only 1 mark. Okay, but sometimes they can modify and they will ask what about the resistances. Okay, what is the relation between current and voltage? I know how the R we are getting. So it's very important. So here we know that if we go for Ohm's law, V is equal to IR. Okay. Then here graph is there in between V and I. So if I write V by R, V by I is nothing but what? R. Okay. Then from this can I write R is inversely proportional to the I? R is inversely proportional to I. Okay. So once you get this, then it is very easy to find out the slope of R3 is means v by I. Slope is nothing but y by x. So here y is nothing but what? I, and this is v. Then R2 having more slope and R1 is having what? Greater slope. Whose slope is greater? Okay, that means that is having what? The lesser is the resistance. Okay, so V by I, that is greater, that means V by I ratio is greater, then R is what? Smaller. So here current is more, then resistance is less. Okay. So from this we can conclude here R3 is greater than R2 than R1. Okay. So R1 is very smaller. So option third is the correct option for this given question. Getting this? समझ में आ रहा है सबको? Then we'll move for reasoning and assertion. Okay, write down. Write down first assertion. You can write down tungsten metal is used for tungsten metal is used for tungsten metal is used for making filaments of incandescent lamp. INCANDESCENT incandescent lamps. Reason: the melting point of tungsten is very low. Melting point of a tungsten is very low. Okay, I'll repeat this assertion. Tungsten metal is used for making filament of incandescent lamp. Reason is there, the melting point of tungsten is very low. Okay, so check what is the answer here. Here first assertion is correct, no? Tungsten metal is used for making filaments in incandescent lamp. That is true. Okay. Then reason they are having low melting point is a wrong. Okay, because they are having what? High melting point. So here assertion is true and reason is false. C is the correct option. Correct. Yes, Hruday. Hruday, you are sleeping. Advait messaged me. Now next one, write down. Electron has, assertion is given, electron has negative charge. Okay. Assertion: electron has negative charge. Electron has a negative charge. Reason: electrons move always from moves always from a region of higher potential to the region of lower potential. I will repeat assertion: electron has a negative charge. Reason: electrons move always from a region of higher potential to region of lower potential. Okay, so what is the correct answer over here? Again here electron has negative charge, correct, but electrons are itself negatively charged, so they are moving from lower concentration to higher concentration. Okay, because they want to fulfill the potential requirement, so they are moving from lower to higher, not higher to lower. So again option is what? C option is the correct option. Okay, means assertion is true but reason is false. Getting this? Chalo, write down next one. Assertion, write down next assertion. Next assertion, write down. Heater wire must have high resistance and high melting point Heater wire must have high resistance and high melting point. Then write down the reason. If the resistance is high, the electric conductivity will be less. Okay, I will repeat assertion. Heater wire must have high resistance and high melting point. Reason, if resistance is high, the electric conductivity will be less. Okay, so which one is correct? Check now. Here heater of wire must have high resistance. Yes, assertion is true here, and the resistance is high and electrical conductivity will be less. Yes, both assertion and reason are true, but R is not a correct explanation for the assertion. Okay, so option according to the given option, B is the correct option. Getting this? Okay, so write down next one. Next assertion, write down. Assertion is given. Connecting wires are made up of copper. Reason, the electric conductivity of a copper is high. Okay, I'll repeat the statements both. Assertion is given. The connecting wires are made of copper. Reason, the electric conductivity of a copper is high. So it is very clear, assertion and reason both are true, and R is the correct explanation for A. So option A is the correct option. Okay, understood? Write down next question. Next assertion, fuse wire. Assertion is given. Fuse wire must have high resistance. A fuse wire must have high resistance and low melting point. Reason is that fuse is used for small current flow only. I'll repeat the assertion here. Fuse wire must have high resistance and low melting point. Reason is there, fuse is used for small current only. So what is the option here? Here assertion is correct. Okay, but reason is what? False. Okay, because whenever there is a excess flow, it is what? Started melting. Okay, so here it is not used for any small currents. So it is used for the larger current. So here assertion is true and reason is false. Getting? Okay, then yes, write down last question, last assertion. Write down, in a chain of bulbs, 50 bulbs are joined in a series. 50 bulbs are joined in a series. one bulb is removed now. One bulb is removed now. One bulb is removed now, and circuit is completely again. One bulb is removed now and circuit is completed again. Completed again, full stop. If the remaining 49 bulbs, are again connected in series, across the same supply, comma, then light gets decreased in the room. The light get decreased in the room, full stop. Reason is there, net resistance of 49 bulbs will be less than 50 bulbs. Will be 50 bulbs. Net resistance of 49 bulbs will be less than 50 bulbs. Okay. So here assertion I will read it out. In a chain of 50 bulbs are joined in a series. One bulb is removed now and current is completed again. If the remaining 49 bulbs are again connected in series across the same supply, then light gets decreased in that room. And reason is given, net resistance of the 49 bulb will be less than 50 bulbs. Okay. So all 50 bulbs are connected in series here. Okay. So they are connected in series across the same supply. And then after that you can remove one. Then we are getting what? They are saying again circuit is connected in a series with the same supply. Light gets decreases in the room. Okay. So if you are having number of applications which are connected in series, current will remain same. Okay, that will not be changed. So here the this is assertion is there, no? That assertion is here not correct. Okay, assertion is false, and here reason is there, that is true. Reason they are saying net resistance of 49 bulb is different and 50 is also different, but it is definitely less than 50 bulbs because we removed one bulb from that. So resistance is what get decreases. So here assertion is false and reason is true. This is what the answer. So last, that is a D bit is the option. Okay. So today I will end this session. So I covered this electricity. Tomorrow maybe I will start the chemistry chapter. Okay. So I will end this. Thank you for joining. And keep studying, do theory. So I will take a test of this. So start studying. If you have still any doubts, you can message me. Okay, we can sort it out. And the questions which I already forwarded, that you can start solving. Okay, getting this? Advait, are you there? Hriday? Now both are sleeping. Yes, Advait and Hriday both are sleeping. Okay, you are there. Okay, chalega. So I'll message on the group, check once.